Welcome to Machine Shop Tech Talk, or welcome back to Machine Shop Tech Talk. If it's not your first time here, in the world of manufacturing, it's not if, but when something isn't going your way and you need to have it handled either today or in the future. On that note, we're going to be talking to my guest today, Dr. Erdem Ozturk, who is an internationally recognized leader in the digital machining field, and he is the founder and CEO of Productive Machines. He has over 22 years of experience in research and development landscape. He is an associate member of the CIRP, that's the International Academy for Production Engineering. He also served as a visiting faculty at the Global Production Engineering and Management MSc program at the Vietnamese German University in Ho Chi Minh. Welcome today to the podcast. Now, obviously, I'm glad that you're here, and I want to know, what do you see is the biggest problem in manufacturing right now in machine shops?
So the biggest problem in the manufacturing sector. So we see that as the waste problem that we are seeing in the sector. So there is a lot of waste in the sector. There are a lot of reasons for it. Maybe we can go deeper into that in a moment. But yeah, we see that there's a lot of waste which could be avoided in the sector. And just to put in the context, all the industries are trying to achieve the net zero emissions by 2050. So having that context and knowing that there's a big waste problem, there is a lot to do uh, to
Yeah.
to achieve net zero targets. But yeah, let's start with the waste first.
Nobody likes waste, right? Once you have waste in a company, that's your money. That could be profit, could be better margins, could be new equipment, could be growth in your company. So anything we can do to eliminate waste is a good thing. So what is
Yeah.
some of the waste that you're seeing right now, and how does productive machining actually address that?
One of the reasons of the waste is unoptimized processes. So in the industry, there is a certain process to go to a machine part. So it may start with the design, computer-aided design, then there is computer-aided manufacturing, then people go to the machine. But until they go to the machine, until they press the cycle start button, usually the manufacturers are blind to the problems related to the physics of the process. For example, physics of the process may cause tool breakages or chatter
Yeah.
vibrations, or they may not say anything on the machine, but when they go to the CMM, they may see that dimensional quality or service quality of the part is not great, and then they go to the CAM again, they change things, but all these changes are based on the experience of the engineer, manufacturing engineer. So that's another problem. The manufacturing engineer skills are getting rare. There's a
Yeah.
big skills gap problem. But even if there was no skills gap problem in the first place, humans are not great in optimizing the machining parameters. If it might, as you said, I have 22 years experience, but if I go to a new machine, new material, new tool, I have no
Yeah.
idea what parameters will work. So humans may be doing some iterations based on their experience, but it's really difficult for a human to make sure that the maximum performance of a given machine tool assembly is used. It's like an impossible task. Usually what happens is they do a few iterations and somebody says, this is good enough. Don't touch it
Yep.
from now on. We made it working. Let's go with it for the next 5 years. Or what happens usually is after every year they may do continuous improvements. They may be achieving 3-4% improvement every year. So maybe they may achieve 20% reduction in the cost at the end of 5 years. But with our technology, we are demonstrating that they can achieve 20% cost reduction in the first week or two. So that will make a massive
That's
difference.
crazy. That's
Yeah.
great. In the first week or two.
Yes, in the first week or two, basically we collect some data depending on the product that we use. So there's a
Yeah.
product, for example, which doesn't even require any measurement from the machine. In that case, the impact can be in the next hour or so. But with our finesse product, which is the flagship product, we basically need some measurement from the machine. We deliver training to the manufacturing engineers to make measurements from their machines. Then they run our optimization solution that is running inside the CAM software. And we are
Mhm.
already integrated in CMAT and CAM and also Mastercam. So if they are using this products, they can immediately start using our solution. But of course, they need to do some measurements, and then arranging a time on the machine may take a few weeks. But yeah, once
Yeah.
they basically do the measurement, they can start using the optimized processes.
That's really cool. I mean, and you covered a lot of waste there, because some people may be thinking as they're listening, they're like, oh, well, that's just the way it is in manufacturing. You set up, then you find out, but that's your most
Yeah,
expensive time. If you can hit that machine more prepared and then
yeah,
reduce the time to finesse. I like the name of the product being finesse,
yeah,
because really
yeah,
that's what machinists do, or the manufacturing engineers have to do, is they
yeah,
have to fine tune it. They take all the data, they finesse the results. But like
yeah,
you said, most shops maybe one, two iterations, and then they say, oh,
yeah,
it's good enough. They do the same
yeah,
thing with the programming that they do with the tooling, with the work holding, with the tool holding, even with
yeah,
the machines that they put it on. They're like, oh, it's good enough. Oh, it's good enough.
yeah,
We also
exactly.
want to bring more manufacturing back to the Western world.
Yeah,
So we can't do that with good enough.
exactly. That's really important point. So it depends on who's your competitor.
Yeah.
If all the
Yeah.
competitors are saying good enough, maybe you'll survive as you
Maybe.
have used to for a long time. But yeah, there are people out there that are really pushing for the maximum potential of the machine.
Yeah.
Then there'll be challenges in getting the orders.
Yeah. Well, and the people that are adopting your product already
Yeah,
are the ones that are going to be, they're going to be gobbling up the work. If nobody else is using it, they've got a huge advantage. That's what it sounds like anyway. I mean, I could be wrong,
yeah,
but
yeah, exactly. For example, we did very two successful reshoring case studies with a UK-based
oh,
manufacturer. The second one recently finished, that just last week, and I was in Siemens Realize Live event
yeah.
last week, so I couldn't present the second one because it had just finished. But I
Oh,
presented the first one. So basically, a UK-based manufacturer has been as competitive as an overseas supplier. So they managed to bring some of the manufacturing back to UK because the
oh, that's fantastic.
tier one company who was the customer
Yeah.
is already a company based in the UK. But because of the cost considerations, they basically subcontracted the work to overseas subcontractor.
Yeah.
And but what happened was there was some delivery and quality issues. So because of the delivery and quality issues with the overseas supplier, they gave a small chunk of work to a local manufacturer, and that local manufacturer told us that, okay, I need to reduce the cost now because I know that in 6 months, if I don't reduce the cost, then I may not have a longer term contract. So
Mhm.
they engaged with us and we gave them 21% cost reduction, sorry, 21% cycle time reduction. I don't know
Wow.
exactly what is the cost saving there, to be honest, but usually cycle time is really associated to the cost reduction. So now
Mhm.
we know that they are really competitive compared to the overseas supplier. And we did
Yeah.
it again last week. So this is not just coincidence. We did it again, and now they have a like much longer contract for the second part as well. So every part
Yeah.
that we support basically, because these are aerospace parts, contracts could be like minimum 12 months, it could be 5 years, 10 years. So it
Yep.
basically brings long-term stability to the companies. So it makes them more competitive, more profitable. Yeah, the result of advantages of using technology to optimize their processes.
Yeah, well, that's super exciting, and I love it because you've got case studies now around
Yeah,
bringing work back, which again, whether it's
yeah,
UK or Canada or
yeah,
US, I just want
yeah,
to see it more in those countries and less in other countries, right? Even Mexico, I'd be
yeah,
happier if it started going to Mexico than some of the
yeah,
countries it's currently in.
yeah.
Because it, yeah, that is so cool. So with both of these case studies, then how did they even start the conversation with you? How did they find you? Because you clearly got them results, but how are they
Yeah.
the lucky ones really that found you?
I think this shows a challenge. Like we have a product that is developed last year. So in fact, we had a product 4 years ago when we spun out from the University of Sheffield AMRC. The AMRC is the Advanced Manufacturing Research Center.
Yeah.
We had a product in our mind. It was working. We had already applied this technology in like big aerospace companies. And then we got investment from Boeing company. So Boeing was our first investor. And then we
Hmm.
said, okay, let's apply this technology into the supply chain of Boeing. And we got
Yeah.
some introductions from Boeing and we started to talk to the production managers or quality managers of manufacturers. And consistently, we got the same message. They said, this looks like a great technology. We didn't think that there was a solution that solves these problems related to the physics of the processes. Because companies are great, but they are all doing simulations to cover geometry of the processes, not the
Yeah.
physics. So they didn't think that that was a solution, first of all, but they liked the solution. But then they said, we need to train people. And we don't want to train people because people are not staying in the job always. So there's a turnover of employees. They said
Yeah.
to us, okay, give us a service. So run the service and give us the improvements in the productivities. And that's why we were able to work with the companies. But then it was not a scalable solution for us. So
Yeah.
then after a few months, we decided that, okay, we really need to convert this service that we deliver with our software to a product that can be used by any CAM programmer.
Yeah.
So now this software is available to anyone, but the difficulty is finding the companies or companies to find us. That was the challenge. So to do that, now we are partnering with companies like Siemens and Mastercam so that we can have more exposure in the industry. But
Mm-hmm.
so far, it's all going with word of mouth. So the companies hear about our solution from a
Yeah.
colleague of them they trust. We have partnership with machine tool builders, cutting tool companies, CAM software companies, sensor companies. For example, one example is Kistler. They are a Swiss-based company. They sell sensor solutions for the machining industry. So they were one of our partners, and they basically introduce us to clients when they hear problems about shutter vibrations, tool breakages,
Yeah.
or when they hear a company saying that, oh, I need to reduce my cost, I need to increase my production capacity without investing in new machine tools. So these are the key words or key statements we tell
Yeah.
our partners to listen for, and they make introductions, and we help the companies afterwards. So this is how it works usually.
Yeah. Well, it's word of mouth is a huge testament to the product, right? If people are,
Yeah.
most people will like something and never say a word. So the fact that people are out there telling other people about it, it just shows how much that you're helping them, because even the good ones, they're like, oh no, I want to keep it to myself. But no, the people that are using
Yeah.
your stuff actually want to share it with others, which is perfect. And I
Yeah.
mean, anyone listening, everything that you just said that you tell your partners to look for, now
Yeah.
anyone listening to us knows to
Yeah.
listen for that conversation in their own companies, right?
Yeah.
Whether they're owners or manufacturing engineers or machinists, they can now think about those conversations and think
Yeah.
about, okay, I am having those troubles. I'm going to reach out and I'm going to get the conversation started.
Yeah.
Especially if they already use Mastercam or Siemens NX, it's going to be really, really simple for them to make that connection. So,
Yeah. Yeah.
what what makes your software work as well as it does? Like how did you even come to realize we needed to include physics in the calculations?
Yeah. So as I mentioned, we are from Advanced Manufacturing Research Center. So I
Yeah.
led a research team there for uh, more than 10 years. And I'm still working there with a part-time role because I have had students who have PhDs.
Mm-hmm.
But it's like a small commitment. My main commitment is with the company now. But over these years that I work with the manufacturers in aerospace, this was always the requirement. So we want to produce more with less cost. So everyone wants to produce more with less resources
Yeah.
because resources in the manufacturing is quite expensive, and everyone is looking for basically being more competitive. And the way to be more competitive, basically reduce your cost, increase your capacity, increase your quality. So that's
Yeah.
always in the radar of manufacturers. And we have done a lot of projects in the AMRC helping large companies like Boeing and Rolls-Royce to reduce their cost. And when we were doing that, we were also developing technology. So it was not only applying the technologies that's available, but we were also developing new technologies. So we had some grant funding from big funds, like in Europe, there was a big fund called Horizon 2020. Now
Yeah.
its new name is Horizon Europe. So those programs fund research projects, typically maybe 5 to 10 million euros. So
Yeah.
I think similar in terms of dollars, so 5 to 10 million US dollars. And then in those projects, like researchers like me have the opportunity to develop new technologies. So we developed a technology through a project called Twin Control. Twin Control was the name. And
Yeah.
when we had this name, there was no even digital twin name in the literature, let's say in the marketplace. So the idea was we would control the twin of the process, and then that will be virtually, and then we will apply it in the real scenario. So that was the idea. So we developed the physics engine behind the productive machines technology in that project. So we were able to simulate the cutting forces and the vibrations. In fact, there's a specific term called vibrations in machining. It's
Hmm.
called chatter vibrations. This is the bad guy. So bad vibrations, it's called
Yep.
chatter vibrations. So we modeled, simulated, and optimized the processes using the new technology that we have developed. We apply this technology in case studies like aerospace and automotive. For example, one of the first implementations was on a company called Maza Aerospace in Spain. And another implementation was on Renault Cléon plant in France. I don't know whether Renault is popular in Canada, but Renault is quite a popular brand in Europe. So yeah,
Yeah,
so we
I'm
applied.
familiar because I had a love affair with rally racing, and Renault does really used to do really really well with along with Peugeot and stuff in the
Yeah,
rally world. So I'm
yeah,
familiar, but it's a car company. Everyone that doesn't know.
yeah. So we helped them, and then we said, okay, we have something here which is looks really good, delivered real impact in real world scenarios, and we have the solutions that are available in the market already. And then we said, okay, we have something here better than the solutions in the market. Let's exploit this. How we can take this to the market. So we investigated, and then finally we decided that the best way to bring this technology to the market was to create a spin-out company, and
Hmm.
then we created the company afterwards, and then we got investment from as I said, the Boeing company, and then we have started growing, and the company is
Yeah.
continuing to grow. And the main mission is basically to eliminate the waste, and to eliminate the waste not only on the big companies but also on
Yeah.
the small and medium sized companies. But
Hmm.
the the main realization to us was, although we were working on the state of the art technology, our impact was only limited to the big players. So we were
Hmm.
not able to play with play, not play, but we were not able to help the manufacturing process of the smaller companies. But now
Yeah.
with this easy to use solution, we are achieving that mission now. We just need to have more exposure and uh, deliver more value to give a bigger impact in the industry.
Yeah, well, and I love that you're continuing to work so that you can support everyone in manufacturing, right?
Yeah,
Aerospace, big automotive. There's
yeah,
some industries that just they have entire continuous improvement departments. They employ
yeah,
many manufacturing engineers just to improve each process. So I love
yeah,
that you're not yeah, you want to help them, of course, but you also want
mm,
to help every machine shop. So
yeah,
as we're tying up the episode, if people are listening and they're like, "Man, I want to see, can this work for my machine shop? Can
mm,
my programmers use this?" What
yeah,
would be some next steps for them? I know you mentioned Siemens and Mastercam. Like, how would they
yeah.
find it on those platforms?
Yeah, so if they Google Siemens and productive machines, I'm sure they
Yep.
will find our product in the Siemens Marketplace. So
Okay.
at the moment we are going through a transition period. So I don't know when this podcast or when this interview will be published, but by the time
Yeah.
it's published, probably we will be there. So Siemens Marketplace uh, is the place that to purchase our solution
Yep.
on Siemens. If you're a Siemens NX customer, we have a Mastercam plugin as well. We are doing some final tuning of that software, and that product will be available in the summer of this year, like summer 2025. The
Okay.
product is coming for the Mastercam users as well. And then there is other cam companies that we are developing integrations for as well. For example, I cannot name it now, but there's a third one coming in
Yeah.
the next few months or maybe early next year. So we are working with the cam companies because we initially had a standalone product, but we thought really we need to be integrated with the manufacturer's workflows. For that reason, we
Yeah.
have integrated our solution into Siemens and Mastercam. So with a few simple clicks and keyboard entries, the customers basically can benefit from this technology, even if they are one week 1 week experience can program.
Yeah. It's so cool that you can take this awesome solution and then refine it to where it's only a couple clicks for people, right?
Yeah,
That's an amazing amount of dedication and an amazing amount of research and development and testing and all kinds of stuff
yeah,
that goes into making that possible, which all
yeah,
takes a lot of belief in what you're doing. I mean, if you didn't
yeah,
believe in this, you wouldn't have put all the long hours in to get here. That's fantastic. And for anyone listening, I will put links down below to the stuff that he just mentioned. I'll have Dr. Erdem send over some links. But I want to thank you so much for being here. And also, you mentioned that you're still supporting the next generation of PhD students. on top of everything you're doing. And I think that's amazing. So many people forget about the students as they get more involved, and you're still out there supporting them. And that's the change we need from the leaders in the space, from the people like yourself that are leading the way in innovation, is to support that next generation of brains. So thank you so much for being here.
Thank you, Arthur. I really appreciated our conversation. Yeah.
Me too. I'm super. For anyone watching the video can see we've been smiling and laughing the whole time. They'll get it. The ones listening, there is a video you can go watch if you so choose and you want to see our smiling faces. To everyone that tuned in, thank you. If you've made it this far, please consider dropping a like. Maybe consider subscribing if you're committed to the continuous improvement of your machine shop and your manufacturing space. This is a great place to come week after week as we release more episodes. And to all of my machining friends, keep your spindles turning and earning.